our next speaker started his career as iOS developer using Objective-C and Swift, and then moved to become head of mobile at LeverX Group. And he's currently managing mobile and R&D teams. His topic will be related to machine learning and mobile. And Vitali will review a create model approach for fast ML model creation and running it on Swift on iOS devices. So possible ways of building and running machine learning models on iOS devices by Vitali Usau.
Right. Thank you. Thanks a lot. Yeah. Thank you. My name is Vitali Usau. I'm currently leading the innovative and mobile department in LeverX Group. And I would like to start from the company and my department introduction, just to give you a little bit more of context of what we are doing and how it's related to the topic I would like to talk today. Sorry, I didn't have enough time to configure animation, so just please promise not read everything else. So when I start from the company. In general, the company is working as a technology partner with a startup and enterprise business, meaning that we get the idea from the startup, build it, and give product back. So in ideal case. We are actually rather big, currently working in 10 countries, 1.5 thousand employees. And the department that I currently work in is focus on native development on iOS and Android, and also on data science. In most cases, these teams work separately, right? So we have products that need to be done natively on iOS, Android, and separately in data science project. But in some cases, when we need to run some magic on the mobile device, we involve data science to work together. And this collaboration is not went good all the time. So that is why I would like to build this presentation and talk about the pipeline of decisions we usually made and how we solve the problem together by both teams. And a few words about myself. So I studied physics and DSP. So previously we didn't use a term machine learning, so it was like working with signals. Then I started working as an Objective-C developer. When I saw the first version of Swift, I just, oh my God, I go to the data science. Just kidding, I love Swift, but I was switching to data science later. And currently, mostly I lead developers, lead teams, so please do not expect a lot of code here today. Okay, the first question that we usually ask before we start building machine learning projects is, where should we run the model? So should it be on the device, in the cloud, or somewhere in the middle? Yeah, this case is also possible. So if we're talking about on the device, or it's also called edge computing, so there are some decent scenarios where you should do it. For example, the projects related to some sensitive data or your private data. If you would like to build the model that will process your messages, your photos, it's better to do on the device, because who knows what can be on this photo, because it can be like document, it should be document, but nobody knows. So we were building a project for the company, for the startup. It was run in the airport where you need to scan your document, and then it should make your life easier and make the border control faster. So definitely the client mentions that nothing should go to the backend. And we need to make an algorithm that read in the passport these 2 lines of symbols at the very bottom of the last page. It's called MRZ. So we make an algorithm that can recognize it, and everything was happened on the device using OpenCV and then a custom machine learning model that was built using Keras. That's like the first example. The second one is like low latency. If you perform something on the mobile device, it's allow you to have a model inference like 10 milliseconds or so, meaning that you can do something like near real time. So you can blur your background on the video, etc. So my favorite point is cost of this solution is like zero, literally. It doesn't cost you anything to run the mobile on the mobile model on the device, and you do not need to scale the servers with GPU, which is not a cheap. And all startups love it because they work in the limited environment, limited budget. And the ability to work offline. You may ask, why do we need to work offline when the internet is almost everywhere? However, part of our clients are corporate clients, and they would like to build something that will work everywhere, even when they're in a business trip, in other offices of other company. They might not have an internet connection there. Or one of our clients says that my employee just used to use airplane mode for any reason. I don't know why. So that is why the ask was, please run everything on the device and make it available offline. Then the cloud computing. So the advantages. There are like 4 points, but the key item is that you have a single place where all happened. So you can control the speed of it. You can update it, and don't worry that somebody is using the old version, right? And so no versioning and less hardware demanding. So it doesn't matter what device you use to open it. It can be iPhone 13, it can be browser, or you can take your mother's iPhone 3, for example, right? So, and it works everywhere. It will be like great. But there is like something in the middle, which is a hybrid computing. There are applications that you all already know, like Shazam, right? Or Vivino, if you like Vine. So we do not know exactly how they work under the hood. However, the goal is that you can take so-called feature vector from the content, like take a picture of something. The model on the device return the vector. That doesn't mean that it belongs to any class. However, it contains enough information so your backend can do a further prediction. And it's great when the content is growing on the backend, right? You would like to make a search through the any goods, any like musician, any like products or whatever. So that's the case for that particular scenario. So perform a feature detector on the device and push it to the cloud. Okay, we are on the like Swift conference, and we will focus on the edge computing, right? So let's assume that we are done with decisions that we need to run it on the device, and we need to decide what technique to be used in order to make it happen. So the first two sections is like TensorFlow Lite and Pytorch. It's actually all about cross-platform. Actually, I would like to ask you who already had experience with running machine learning models on the device. So could you please raise your hand? So just, oh, that's good. And something from TensorFlow Lite and Pytorch Mobile. That's also good. One person. Okay, that's all about cross-platform. When you need to run something on iOS and Android, you go with one of them. The only difference, Pytorch Mobile is not supporting on-device training right now, but nobody cares in this case. So it can be run on the mobile devices on iOS and Android. And we do not have a lot of experience, to be honest with you. It's not something that marketing department would like me to say, but with TensorFlow Lite, we built only one product where we actually make a recognition of beer cases. So it was a corporate application where the user take a picture of beer cases in the store, and it can recognize what are brands on the picture. And it needs to be run on the iOS and Android, so that is why we go with TensorFlow Lite. But let's move to the iOS specific topics. The first one is metal performance shaders. So what it gives to you, it gives you full GPU performance, so it doesn't limit it anyhow. It doesn't allow iOS to make optimization like with Coromal, but it not easy. So the disadvantages of it, it contains a lot of layers, so you can build any network you like, but it will cost you like time that you will spend on understanding how it works, and also chatting with data scientists, because it requires from you to understand how it works actually inside. Let's switch to the Coromal. The Coromal is the only actually tool that allow you to use not only like CPU or GPU, but actually Apple neural engine. You do not have a public available API for it, so use Coromal if you would like to use it. And that's great because this engine was introduced on iPhone 8, and since that, so everybody promised that it will like run super fast. And we saw the evidence of it. And also, the CreateML allow you to use Coromal allow you to use CreateML using Swift and my favorite UI. So when it was released in 2018, I was like watching for this WWDC with our local iOS community, and it was like, wow, really, you just use a drag and drop and you get the model, so why do we need all data scientists in the company this way, right? So you just can build it by iOS developers only. So that was like a really cool feature that we like. But it gives you less control. We will talk about this disadvantage today later. But it's not so good, so you need to pay for this convenience. And the last item is like do it yourself. So you can do it using like Accelerate framework on Apple, like OpenGL, third-party libraries like Blender. Actually, the Accelerate framework is also good. It's allow you to perform like digital signal processing on the device, on the edge. We were making one tool which actually like recognize piano playing when you play as a user, so it can hear you and say, well, this is a note mistake or this is a timing mistake, like you play the note in the wrong time. And finally, it can evaluate your playing and give you a score, like you perform 80 out of 100. And this is like the report where you make a mistake. So it can be done using Accelerate framework easily. A more complicated model was built on Coromal. However, Accelerate framework allows you to solve like linear algebra equation and perform like simple like machine learning task really fast. But let's jump to the Coromal, right? So in order to show you all pros and cons of it, we just take 3 data sets in order to show on based on it like simple application, training, and all pros and cons. So the first data set is so-called Mani's data set. If you a data scientist, you might say, well, this is like the basic framework, data set available, and that's true. That's why I take it. The second one is also and regarding the first Mani's dataset, it contains actually 10 classes from 0 to 9, and it's like handwritten digits from 0 to 9. And the task is to recognize what was written, so simple. The CFAR10 dataset is also 10 classes, so that was the idea to take something with 10 classes, and you'll see why. And the classes are much more complicated, so it's like horse, plane, sheep, etc. And sometimes even a human cannot recognize it, so that's not so simple. Again, it's like really small data set in terms of like size, 32 by 32. And the size of the whole data set is the same as Mani's, is like really big. It's like multiple K of images, like 50,000 for training and 10,000 for validation. And the last data set is something close to the reality, because usually when you build a like image classification task, and we are talking about image classification here, you take a picture of something by using your iPhone, and it's usually a big picture, and in real life you do not have thousands of images to train your model. Usually the clients came to us and say, look, this is like 100 of photos. We have 20 classes. We require 100% of accuracy. And we say, good, thank you for this information. So let's try to work on the additional data. There are some augmentation technique when you add noises, when you can flip it or like turn it a little bit. That's help you to increase the data size, but it's never enough. So it cannot just replace the real data. So that is why the third data set is not so big as the previous one, but has a bigger side. And what we actually did with all of these data sets, we, as I mentioned, just put it, use drag and drop, and feed the CreateML with it. And what we have, the accuracy for the first one is like 83%, almost 88. The model size is 152K. For the second one, the accuracy is lower because, as I mentioned, it's hard even for human to recognize some cases. But the model size is the same, right? So that's interesting. And on the last one, the accuracy is also above 80. It's around 80, and the model size twice bigger. When you first see this result, you might think, why we have like the same model size where the data set, like the input images have different sizes, like 28 by 28, 32 by 32, but the outcome is the same. We'll see it later when we make some surgery on these models. But then our data scientist takes this data set and just tell me, like, hold my beer and watch how it should work. So they take the models and they provide their own results. So for the first data set, for Mini's data set, it's really, we get 98.6%, but state of the art is 99.7 or so. So you can visit Kaggle. It's like a platform for the data scientists where there are a lot of challenges and the user just working with it. But the size is bigger. The second data set, the team gave me 88, and the size was 3.1. And they trained everything in a single day. So I just tell them, you have 1 day, I have presentation tomorrow, so please prepare it. Just kidding. But the 1 day limitation, that was the truth. And for the last data set, what they returned back was the accuracy 91 and the big model size. Again, the data scientists also like cheating as CreateML. They can take the real model and train it, so they do not invent a new architecture each time. But anyway, as you can see, the model size is bigger, and but the accuracy is better. What I can in order to understand why it's happened, let's make some surgery, right? So we take a CreateML model that was that we received as a result, and let's see what is inside. There are like multiple ways how you can look inside of the model. The easiest one, you can use the application Nettron, which actually show you the architecture of the model inside, and see it's like by layer. And what we can see here is that input image with the size 299 by 299, and it doesn't matter which data set we use, it's always be the same. Meaning that if you even have some small images, small like Mini's dataset 28 by 28, it always require you to upscale it. So that how it works. But why it works in that way in CreateML? The answer is the second layer, is vision feature print. So Apple have their own model that was trained, and as the Apple mentioned in the documentation, that they train it on multiple millions of photos. So it gives you a black box. You always can consider like neural networks as a black box that in our case an input is an image 299 by 299, and the output is a vector of double values with 2048 values. And this vector contain like all meaning of the image. but it wasn't trained by us. So it's trained by Apple. So what gives us, it gives us a much faster training, because the big part of the network was already trained by Apple, and you need to train only the first few layers. And the third layer is actually, this is like fast layer, GLM, or General Linear Model Classifier. So some boring thing, that how it's work inside. So as the input you have 2048 doubles, and it's connected with n classes on the as an output. The n classes, in our case, it was 10 for MNIST, 10 for CFAR, and 23 for dogs and cat breeds. So, and this, what you can see actually, the more n you have, the bigger size you have of the model. If the n is equal, the size of the model will be equal. So that is why our two-phase dataset has exactly the same size of the model, and it doesn't depend on the input images, because it always needs to be aligned with the model input, which is 299 by 299. And that is why the training time is less than in custom models that you can build in Keras, TensorFlow, and then convert to Coromal, because you don't need to train this vision feature print, which is also a part of the custom models. And the last like 2 layers is like string class label, is the simple operation where the iOS takes all probabilities, sort them, and align the class name for each probability. So at the end, you can see like this is like the cat with probability of 98% or so. So that how it works actually inside. Let's see actually what it gives to us. Like create ML vs custom model for image classification, because there are a lot more different tasks, not only image classification. There is like segmentation, object detection, tracking, etc. We were focused on, as I think, like most popular task for the mobile devices. The CreateML training is fast. This is because you do not need to train the whole model. You just train the last layer. The CreateML can compete with custom models on small amount of data. That is again because it was pre-trained on something. The model saw some images before, so it understands what images itself, because the pure neural network has no ideas about the environment at all. In our case, in the case of CreateML, it's already have some feeling that there is something outside. I've saw like 1 million pictures, and it can be easier for this model to train on new data set. And CreateML doesn't require any data science skills. That's true. And actually, that's great because it can be used by iOS engineer, and it doesn't require iOS guys to dive deep into the deep learning, right? So you just take data and you get the model, which is super great for so-called like baseline solution. And what are features for custom models? For the custom models, we have much higher score, actually, because it's tailored for your data, tailored for your need. And if you are a startup with unlimited budget, you can play around with the architecture and make it high accuracy and really fast. Also, custom models allow you controlling the model size and controlling of the accuracy. You can have a bigger architecture which make it slower, and you can make a smaller architecture and get like accuracy not so high. So depending on your needs. And also, custom models are not limited in terms of augmentation technique. If you play with CreateML, you might notice that there are some things where you can, for example, add augmentation to your data, like add noise, right? Or rotate it, or flip it. So depending on the nature of your data, you can apply one technique or another. But there are a limitation of the CreateML tool, so they are not supporting it a lot, especially in audio signals. If we have time, I also prepared some slides for that, but I was thinking that I will be running out of 35 minutes, so we can jump to them as well. For the audio classification, the CreateML doesn't have anything like that. But custom model allows you to do it. So what we have also here is the summary. So I prepared the keynotes of this presentation, but the idea was to publish it somewhere online. So if you'd like to, you can take a screenshot. There is like a summary of the presentation, some materials, books. It was published on our news corporate website, so feel free to jump to it. And I don't know if we have time, we can jump to the audio. Okay, so we can jump. So I can also tell about audio classification task, because image classification is the most important, I would say, and the most frequently used in data science. However, there are much more other tasks, and one of the popular one is audio classification task. So this is the previous one. The previous examples were like synthetic, right? So we take data sets, popular data set, and play with it. This is like from a real project and from a real customer. The customer came to us already having the model, and they telling us that it's already 97% or almost 98%. I was thinking, and why do we need us? So 98% is something really, really great, actually. But what they're trying to do, they try to perform the classification of the audio, and the input was the environment sound. Unfortunately, my customer tell me not to tell the exact use case, or not to show the data. Like, so we need to select whether we are discussing use case or show the data. I select data because as you know, that developers maybe not so interested in use case, but more interested in data. So I cannot tell a lot about the classes, about the use case, but let's assume we have 7 classes. We have 3 hours of audio prepared and classified. And there is a model that was trained using CreateML and give us like 98% of accuracy. That was like, wow. But then we start diving deeper, and we saw that there is like problem with the data, and we saw one limitation of CreateML. And the CreateML actually, as you remember, it's require separate folder per separate class, right? So you, if we talk about environment sounds, it can be, let's assume speech. The one folder number 1 contain only speech. The folder number 2 should contain only like bird sounds, right, or whatever. And then you just feed it to the CreateML. However, life's not so easy. So in our case, it was audio signals where you have multiple signals at the same time, and CreateML is not designed to work with it. So that can be solved only using custom models. And another problem that we have is that it's not like designed for some classes that some sounds that at the same time can have 100% of one class, 100% of second class. For example, CreateML model cannot tell you that, well, this is like 100% of speech and 100% of birds on your sound. So it can be like 50 by 50 or 60 by 40, etc. So it's always sum up it and give you like sum equal to 1.0. So what we did, we used Pytorch, we trained the model, and we converted it to Coromal and run it on the iOS. So the model was gives 92% of accuracy, but then again we test the CreateML model as it should be tested and get 85. So yes, we won with custom model. The model size was bigger a little bit, but it was faster. And it gave us to the audio classification keynotes. So CreateML is supposed to be trained on 1 class per data sample, and that's not always the case. There are no augmentation at all, so you cannot just add noise to your audio automatically. So you need to do it manually. So it can be done using CreateML. The constant sampling rate is 16 kilohertz. You may already know that if you have 16 kilohertz of sampling rate, the highest frequency will be twice lower. So it can detect only kilohertz sounds. Everything higher will cause you problems. But you do have sounds with a higher frequency, like even if you have a piano playing, right, the highest note are higher than 8 kilohertz. The window size is fixed in CreateML. It's like almost 1 second, which gives poor timing resolution. So you cannot be pretty sure when the sound was played, or you can hear the sound. So that is a problem, the pure resolution. And as we talk, the sum of all probabilities is 1.0. Making a summary, CreateML with Coromal. So from my personal opinion, the CreateML is really great when you need to build something really fast and you already have data. So it's like great thing for startups, and we saw that a lot of startups do it by themselves, so they don't need like data scientists, engineers to build the first model. But if you're a lucky startup that you have a budget and you have investors, so definitely the way to go is go to the Coromal. Custom models, custom training. So in that case, you will tailor your model for your particular need, and it will perform better. And in some cases, it can be lighter in terms of the size of this model. Well, that's it from what I would like to share with you. Hopefully, it was useful, and I will be more than happy to answer any questions.
Yes, we have 4 minutes, and I see.
Yeah, one thing, we have a small present from our company for the best question. So I guess we will have more hands.
I think answer would be even better. I have a question regarding preparing training set for Coromal. Do you need to scale the images yourself, or does Coromal does it? And I ask because if Coromal does it on its own, then maybe changing how do you prepare the set, and maybe changing the algorithm to some, I don't know, Fourier or nearest neighbors, or boxing sampling or something like that could impact the performance or the accuracy even better.
Yeah, great. Thank you for the question. CreateML will do everything by itself. So all scaling, everything will be prepared. The data sets that we have number 3, where we have cats and dogs, it was not with a fixed image size, but with various image size. However, it can make you like just push everything that you have to the solution and give the model. But I would advise, first of all, to think to see what you have on your photos, and first of all, it should be represented, right? And the size should be close to the size that will be used in production. So if you take photo from your camera, the resolution can be different, but at least try to have the similar aspect ratio. So it will be better, because when it's resize as an input for the CreateML, and you will have landscape pictures. So the cat that can be in the middle of the picture will be like really one line. So try to make your data set close to what the model will see later. So in terms of aspect ratio and aspect of size, that will increase the quality definitely.
Can I have a follow-up regarding? So basically, okay, sorry. So basically, does it always change the size to 199?
Right. So if we're talking about classification, it's always change it to this way. And if you feed your images using Vision framework, it will automatically align it. However, if you use a custom model, that is a benefit of custom model. If you have a small input images like 28 by 28, you can make a smaller network, but you have to do it manually. You have write a code that will minimize image and push it on the input.
Okay, because I'm wondering how much can you improve accuracy of the core ML without going fully to the custom solution. So basically, like preparing the set, and I'm wondering if you maybe checked how changing the size and scaling on your own and preparing the set impacts the core ML and its accuracy. What's the difference in like when we have all variety of the images in different sizes and we use different algorithms to prepare a training set, and then we use Coromal on all of these training sets?
Are we talking about Coromal custom model or CreateML?
No, the native one that is provided with the Apple with the context knowledge.
I see. Yeah, actually the difference won't be big, so it can be like 1-2% or so. Again, but it's always depend on the quality of your data set as well. So it should be like representative, meaning that each folder should have pretty similar amount of images. Yeah, it shouldn't be unbalanced when you have one class 100 images, another like 2 images or so. I really just advise to work with this aspect ratio and size before it. But again, you will win maybe 1 or 2% or so. It's not will be big, because the bigger advantage can give you a custom model where the architecture is different. It's tailored for your task, so it can be better.
Okay, thank you.
Okay, anyone else want to fight for the prize? Oh, we have one hand.
Okay, thank you for your presentation. So I would like to ask about specific use case. So for example, we would like to recognize a human action or some kind of action on the video frame. And in the custom model approach, we can use some kind of LSTM networks or CNN networks. What about the create ML? Does it have some kind of limitation on some like series of events or like recognizing some events on the video?
Actually, it has some action recognition. So, and the vision framework has some like logic that can help you with it, but again, it's pretty limited. So the CreateML, as far as I remember, it has like action recognition and maybe some points on the body recognition on the face.
So kind of holistic, right?
Yeah, but if you would like to do something custom, for example, if you would like to analyze like basketball games and the like behavior on the field of these players, so you should better go custom, I would say.
Okay, thank you.
Thank you, and I think we're running out of time, so Vitali, you need to choose the winner.
Yeah, the winner, I would say the first person, so I like the question regarding the dataset quality, because it's something that needs to be done. Yeah, actually, there's like a small souvenir from our company. Yeah, if you don't mind. So thank you. Yeah, thank you. All right, great. Thank you so much.
Thank you for the talk, Vitali. Okay, and 1 second before you go for a break, there's one more announcement. As I said, you can win a prize on the LeverX stand, but also on the Revolut one. There is a screen that you can play some games, and you can win a wireless charger or AirTag. So please go there, check what you can win, and winners will be announced tomorrow. And you can go for the cake break now. Thank you.